We've already learned how to take the derivatives of a lot of functions. Trigonometric functions, inverse trigonometric functions, exponential functions. But we're somewhat limited in the sense that we have not yet differentiated the logarithmic function. So let me give it a shot. I'll start off with a special case where the base is e. In other words, let's see if you and I can't differentiate the natural log of x. So here I go. Exponentiating both sides. Treating y as a function in x, I'll differentiate implicitly with respect to x. Solving for dy dx. And I've done nothing wrong, but it's kind of nice, if at all possible, to express dy dx in terms of my original independent variable, and I can. Because I think another name for this denominator, according to that relationship, is just x. So I think, oops, sorry, that board's not clean, is it? Oh, I should have set myself up. I didn't know it already had a mess on it. What I'm trying to suggest is the following. You and I have just concluded that to differentiate with respect to x, the natural log of x, we're left with this. But I have more to say. What about that? It's logical, because if x numerically is negative, I'm taking the natural log of a positive number, so the function is defined, as long as x is negative. So does that not mean this? However, it is the case that this right here really is negative x. So when I put the negative x in, these two negative signs completely cancel each other out. What I'm trying to suggest is that whether I'm taking the natural log of x or negative x, I get the same derivative. So that tells me that to differentiate with respect to x, the natural log of the absolute value of x, I'm left with this. Now, please don't take this the wrong way. This isn't going to be ground shouting for us right now, but next semester, it'll be huge. So next semester, when I undo the differentiation process of this thing, I need the absolute value bars in. For now, it's not that important. The only thing I'm missing is this. I restricted my attention to a logarithm whose base is e. What about a logarithm whose base is not e? Where, of course, I'm sure you understand that a itself is strictly positive and not equal to 1. Well, to differentiate a logarithmic function whose base is not necessarily e, let's go back to our favorite math class. That is to say, 9th grade algebra. So I want to differentiate with respect to x, this. But I only know how to differentiate a natural logarithmic function so far. So why don't we just force the natural log function to exist inside the parentheses? Using one of your basic logarithmic properties, I think the log of x respect to base a can be interpreted as a ratio of the log of x to the log of a with respect to any base I darn well please. I'll choose base e. Now that denominator is just a constant. I'll pull it out of the differentiation process. But the derivative of the natural log of x is merely this. What I'm suggesting is the following. To differentiate the log of x with respect to base a, I still get what I have up here, 1 over x. I just have a coefficient downstairs in front of x, the natural log of this base. And check out what happens if this a happens to be e. We know what we should get. But if a is equal to e, this parentheses factor is nothing more than 1, and I do get just that.